Hello everyone, this is N. Kavita working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. And today's topic is about the application of LVDT. LVDT is nothing but linear variable differential transformer. And here today we are going to focus on one specific application called measurement of pressure. So how we can able to measure the pressure using your LVDT. We'll have a short recap on what is LVDT. So this LVDT is a differential transformer. It is an electrical transducer or a sensor where you can able to measure any kind of physical quantities like displacement, force, pressure, acceleration, etc. And these kinds of non-electrical parameters are converted into an electrical parameter with the help of LVDT. And this is working on the principle of mutual inductance that generates an electrical signal which will be always proportional to the physical quantity whatever you apply. You know that already what is the basic working principle of this LVDT? The major input of this LVDT is going to be the displacement, and this displacement is being converted into the electrical signals. So the major case of using this LVDT for the use or measure of pressure. So here we will see how this pressure is being converted into an electrical quantity, and definitely the pressure cannot be directly converted into an electrical quantity. So this pressure has to be converted into a displacement, and those displacement is converted into the electrical quantity. We will see how it is working. How to measure a pressure using this LVDT. Before getting into the application part, we must know about the construction of LVDT. LVDT will be having a primary winding which is connected to the AC power supply, and there will be two secondary windings on either sides, and these two secondary windings will be connected in series with each other. And those windings are placed inside a former. In between this primary winding and secondary winding, we have got a magnetic core, and this core is used to make your displacement. Hope all these things are clear to you from the constructional part of the LVDT. With the support of this construction part, let us move forward how to measure or how to sense your pressure using this kind of LVDT. So we have one recap on this construction part. So to sense a pressure, always a specific device or a specific instrument is required, and that is called as a bellow or a board-on tube. So what is this bellow or what is this board-on tube? So this bellow or board-on tube is a kind of a tube which is in such a manner where you can able to apply a pressure. And this arrangement is called as bellow, or sometimes it is termed as board-on tube. So this is the main part which is acting like a pressure sensing element. And now this pressure sensing element along with this LVDT is going to convert this pressure into the electrical voltage. So we will look on in detail about the working of this LVDT and how the pressure is being converted into the output voltage. So before getting into this, you must know in detail about your construction of the LVDT, which is already given in the previous slide. And now, when you look at this diagram, you can able to identify that at the bottom we have got some bellow, and this bellow is being connected into a setup. And what is happening here? Right. So before getting into the application part, you must be able to recognize the parts which is present inside the diagram. And this is what I told you. It is called as a bellow. With the help of this bellow, I'm going to apply the pressure, or the pressure sensing element is called as bellow, or in turn it is called as the board-on tube. And this board-on tube is a pressure sensing element, which is already stated. And this bellow is connected with a kind of a setup. You can able to see in the top end. So the part which is present at the bottom, this bottom part is a pressure sensing element. I can make it as the pressure sensing element. This is the bottom. And at the top we have a complete setup, and this setup is nothing but LVDT. Fine. So now this pressure sensing element is being connected to the part of LVDT. You can see here, you can able to recollect the construction part. We have got the primary winding, and it is obviously understood that it is connected with the AC power supply, and there are two secondary windings, S1 and S2, and the voltage of S1 is mentioned as ES1, and the voltage of S2 is measured as ES2, and the differential voltage is applied. So since we are applying a differential voltage, this kind of transducer is called differential transformer. Why it is called a differential transformer rather being called as differential transducer? Because we have got a winding here. Whenever you can able to find these two winding and whenever there is a transfer of voltage, we call them as transformer. And that is why we call LVDT as linear variable differential transformer. We'll get into the application part right now. So how this is all interrelated and how we are going to measure your pressure. We'll have a recap now. So you can just rewind about your applications of your LVDT, and by this time you can able to recollect the working modes of the LVDT, and there are three working modes, case 1, case 2 and case 3. Keep in mind, and in case 1 the core will be null position, in case 2 the core will be at the left of null position, at case 3 the core will be at the right of null position. And now what happens when we apply a pressure? So when I apply a pressure, what happens here is this bellow will sense the pressure. I'll make it short here. So there is a pressure which is applied over here. Yes, this is a boron tube. I'm applying a pressure over the tube, and this tube, it is understood that there will be a pulley over here. You know what is a pulley? A wheel-like arrangement which is used to rotate the part. And followed by that pulley, we'll be connecting with the LVDT. So whenever I apply pressure, based on the pressure, this pulley will start to rotate. So this pressure is applied into the bellow tubes, and based on the pressure, this core will start to move. So the movement of the core or the displacement of the core is provided by the applied pressure. So based on your pressure, when your pressure is high, the core moves here. When your pressure is low, the core moves here. So here the displacement is provided in terms of the applied pressure, and this applied pressure is being sensed by using your bellow or a board-on tube. So I'll make it clear once again. So the pressure is applied and the displacement of the core is happening only because of my pressure. So whenever I apply a pressure at this part, the pressure is getting here, and you assume that the pressure is reached so far here, so that my core is shifted at this position. And now it is very clear, the core is getting moved towards the S1 location. So when the core is at S1, or when you know the condition, ES1 will be greater than ES2, right? So whatever the voltage is associated with this S1, which will be greater than the voltage associated with the secondary winding S2. Say for example, if I provide a voltage of 4 volt in the secondary winding 1 and 2 volt in secondary winding 2, the output voltage would be the difference between these two voltages, that is 2 volt, or this 2 volt is the output voltage which is obtained in proportion to the pressure applied. So this pressure, applied pressure, is proportional to the output voltage. So I can take this output differential voltage as the amount of pressure which is provided into the LVDT. Hope the application part is clear to you. So here one more thing which we have about to focus is, there is a concept of primary winding and secondary winding which you have to understand, because this is a very simple part. Here the displacement is not done manually. That is the only difference. Here the displacement is done based upon the pressure which is applied. So based on the pressure applied, the core is starting to move. So the core is directly, it is not connected to manual displacement. That is the only difference. The core is connected to the bellows, and based on the applied pressure, the bellows is moving this core. So what is the one thing which you have to keep here in mind is, there are two types of transducer called primary transducer and secondary transducer. So what is primary transducer? So here I cannot say that the pressure is directly converted into the output voltage E0. In between, what is happening here? So first the pressure is being sensed by bellows or the board-on tube. So now I say these bellow as my primary transducer. This is called as the primary transducer because it is not possible for me to convert the pressure directly into the electrical voltage. So in between, I need a primary part or a primary transducer, and that is called a bellow. So it first senses the pressure, and this pressure is now converted into a displacement. Right? So how this is converted into displacement is this bellow tube is connected to the core, magnetic core of LVDT, and this LVDT magnetic core displacement is taking place based on the pressure I apply to the bellow tube. Once the pressure is converted into displacement, I go with the concept of LVDT, and now this LVDT is called as the secondary transducer. So why it is called secondary transducer is it doesn't directly convert the pressure. So initially the pressure is converted into a displacement with the help of bellow. So here bellow is my primary transducer, and now have obtained certain input to the core of LVDT, and based on the displacement of the core with respect to the pressure, there will be a flux linkage and generation of differential output. Hence LVDT is called as secondary transducer. So hope this application part is clear to you. So we will see the working now. So when your core is placed in between the primary and secondary windings, you can have your output voltage. So when your output voltage is 0, when your core is at null position. And based upon the pressure, we'll have a short recap on the slides. When the pressure is applied to the bellow, it deflects, and there will be the movement of the core of LVDT. So when this core is lifted up, or when it is getting close to S1, there will be more voltage induced in the upper part, which is nothing but ES1. Yes. So the positive voltage is being generated. In turn, whenever this is moving towards the decreased below, the moment of the core comes down, which means it is associated with the secondary winding S2. So ES2 is greater than E1. So in this way, this LVDT type pressure transducer will operate on an output voltage, and this output voltage is obviously proportional to the applied pressure. What is the main advantage of this? So here the sensitivity will be very high, and it will be having a good low hysteresis loss, rugged constructions, and a very good repeatability. The main disadvantage is pure accuracy. We cannot say it is a major disadvantage because the pure accuracy happens because of the way the pressure is being applied gradually. So the performance of this transducer will be definitely affected by the temperature. Hope this video is helpful to you. Thank you.